Okay, everyone, we are live. And there I spoiled the next video. Anyhow, let's see. So I will connect to my jump host and I will go to Code Planet. I will attach to my screen, and I have never actually explained what this screen command does. If you were to close this window, then you will be disconnected from the server and everything you have done on the server will be removed unless you have saved. So the programs will quit and yeah, like that. However, if you run it in a screen, then you will get two benefits. The first being that you can use some keyboard commands to create new screens. So a screen is a full-sized window, so to speak, with a terminal in it. So I can, for example, be in one directory in this screen, and I can be in one of this. And I can also be on different servers and stuff like that. And the second benefit is that if my internet connection were to go down now, then I can just reattach to my screen and everything is exactly the way as it was. Alright, so let's see. I will try to I will close down some of the old windows and see if I can find this project. What did we call it? We called it webdev.something.c. There it is. I will set this directory to my, no, that's not it, home. And as I mentioned before, 15 minutes before the stream started, my USB adapter broke. So I had to choose between the keyboard and the there it is. I had to choose between the keyboard or the mouse or the good microphone or the internet connection. So I changed to some small bad keyboard, which is remote, what do we call it, Bluetooth. So I don't have the USB problem, but I will probably do a whole lot of typos today. And if you wonder why, that's why. Let's see, we have this, and let's create another one. We go to TMP, we go to webdev.c, and we set the home to the current working directory, like so. And what do we have in here? We have an H file, a C file, some temporary thing, and a make file. The temp file, I think, is the example how the framework will look to the end user when he uses it. Yeah, it's like this. So you basically define a DTO, data transfer unit, and you specify in a struct the data that you want to receive. Then you use this macro to bind a post request to this function. And all of these functions takes a request object and a response object. And it works quite similar to the JavaScript frameworks like Nest.js and Express. So we, for instance, get the user from this request object and credentials and username. Same with password, and then we can just do a string compare. We can set the session. We can return JSON. And for those of you who has never come into contact with the JSON, it's a what should we call it? A file format that JavaScript uses, and nowadays every language uses it in order to store objects, data. And it's very easy to serialize data and put it in a JSON file and deserialize as well. Alright, so, and then we can send an HTTP error by setting the error code like this. So this is how I want the end product to look. Let me just take a couple of sips of water. Alright, I'm back. And we have 10 viewers. That's better than the last stream, so we go in the right direction. Alright, so I would, as usual, I will use the Sociopath SCP client in order to code remotely against the server. I can put it like this. So in this case, I will find our webdev.c, this one, and I will open it in editor. That basically means that it will download the files. It will, let me just close this real quick. And resize. Well, it will open the directory remotely on the server, and every time I change something or create a directory or something like that, it will automatically update against the server. So let's see, I want the right size of this one. You have to tell me if the font is too small, in case you're watching on an iPad or something. But I think this should be kinda enough on a 1080 resolution. Font is good. Good. Alright, so let's see what we have done this far. The make file is pretty self-explanatory. It just compiles everything the usual way. So that's not much to talk about, but we have the C file and we have the H file. And this was rather big still. Let's see, maybe I can do this. No, that's wrong. If I make this a little bit bigger in this direction, I can probably move it down there. Alright. So let's see what we have here. Let's start in the C file. Right, we created a main function which takes two arguments, right? Let's check the usage. Yeah, it takes a port number. That's the TCP port number to listen for incoming connections, just like most web servers. And we have an additional option of specifying what IP address we want to listen to in case we have several. If we don't specify that, it will default to this all zeros IP address, which basically means listen to all IP addresses on the system. Okay, so we set all the variables, then we write to this buffer. I wonder if this is wrong. We write to the buffer, right? But then we don't do anything with this thing. So I suppose what I was aiming for was to log this message. So let's do that. And since our buffer is already set up, we will just do log buff. And if you wonder what this log command is, if we go to the H file, we see that this is a macro which will call our function syslogger and supply the argument log info. So that's basically a standard log message, informational. And then we send the string. And we also have log warning and log error with these two macros. And if you wonder what all of these weird looking things are, when I use my own types like this, so I use int 8, int 16, int 32, and int 64, rather than just int, or tiny int, etc. And when I do that, I will have to cast a lot of things, and this makes it easier. So I just type $8 instead of int 8 star, for example, and so forth. So now all of you who hasn't seen the original episode, you should be pretty caught up. But let me just ask you, do you have any questions? Because I want everyone to be able to understand what we're doing today. And MindHive, yes, I do. Doing a project, and especially doing a project of your own, where you are passionate about the topic that you are coding, that is for sure the best way of learning. So most of you have other interests too, not just computers. So let's say you're interested in computers and you're interested in golf. Try finding a way to code something for golf. Maybe something which calculates all of these different bogey and birdie and keeping score and making diagrams and I don't know, stuff like that. Because when you do a project which is based on your own interest that you're passionate about, then you will learn incredibly fast. Everything is clear. That's what I wanted to hear. Great. Then let's continue. So let's see. We listen to the port 80 and we have this main loop which deals with all of the connection related stuff. When we get a connection, we will fork, which basically means we'll split the process in two, and the main process will continue listening for new connections, and the sub process will deal with the request from the user, so they can do it in parallel. Okay, and I put a couple of lines here. I think what I mean by that is I should add stuff to this function. And I think I know what, because I want to keep track of the state somehow. So basically I want to be able to let the user have access to the IP address and the port number and stuff of the people that surfs into his website. And in order to do that, we need to save it somehow. So we need to keep a state, a database, an in-memory database with the different information that we need. So let's start by creating a structure for that. And let's see, we can put them here, I guess. So let's just call them S for struct and then state. No, that's not the right one. Two of my keys on the keyboard has moved. They have switched places since I changed the keyboard. So that's a little bit annoying. Alright, what do we need? We will have the file descriptor of the socket. Let's call this, it should probably be an int32, I guess. Let's see what we used in our other parts of the program. Int32, that's right. So this will be the socket file descriptor. Another thing we're gonna need is the it is the IP address. And should we save this as a string or as a number? It's a little bit more optimized saving it as a number because it doesn't take up as much space. However, it will be a little bit more messy to deal with when we want to access the data. So let's make our lives easier and simply create an int8 pointer, which is a string. And let's call this IP. And then we will have an int16 for the port number. Maybe we should also save the different parts of the request. Yeah, I think so. So how should we do that? I think we will create another structure for that and put it inside of the state, because I want to use this for several things. So this will basically be the request object. So let's call this sRequest. And let me find this. There we go. And what makes up a request? We can have let's say a method first. This is basically get, put, head, and so on. Like so. And in addition to the method, we want to have a path that we can make an int8 pointer path. So this will basically be slash index HTML or something. What else do we want to save in here? We want to have the cookies and the headers here as well, but I don't want to define all of those at this point. So let's do something like this for the time being. I will mark these as temporary, and I will do type def, and let's just make those, I don't know, something temporary, bool, and we will simply call this headers, or header, and I will do the same for header and cookies. That way we can put this inside of the request object. So we'll do header and header. And this should be an array, right? So let's do a pointer instead, and plural. So this will be the headers. All right, and we will also create something for the cookies. And we'll use the same thing here. So what do we have? We have the request object with a method, the path, the headers, and the cookies. And the state will contain this request object. So this will, but let's, before we do that, let's create the type definition as well. Because I always create first a struct, and then I do a type definition against that struct, so I get a little better name for it. So I'll call this request with a capital R, and that way we can simply do request, and let's see, let's make this a pointer. No, that's a little bit too much heap stuff. I think we can do this as a value. So this will be the request object. Or maybe we should do it as a pointer anyway. And before I forget, I will add this semicolon, and I will do a type definition for this as well. So the struct as state will be just state. And what else? The methods. Maybe we should use an enum for that. I haven't used them a whole lot before, but I think this is a good way to use them. So I will create an enum, which I'll call e, and what was it? The method. So e method. And what will it contain? Well, to begin with, we can add more methods later on, but at this point we will have, let's see, I think it's like this, right? 1 equals get, 2 equals post. I think it's done that way. And then we can do a type definition for this as well. So the enum e method will be just method. Alright, let's see if I did the enum thing correctly and see if this stuff compiles. So we'll do make clean, we jump down a little bit, we clear the screen, and we run make. Okay, we do have an error. expected identifier before numeric constant. Okay, that's a pretty good error message, don't you think? It exactly explains what we did wrong and how to fix it. Maybe in the future, when we have AI-based compilers, we will always get this kind of error messages. So instead of doing this, I will do this. And if you haven't worked with enums before, it's basically, it's good when you have some different options and you cannot combine several of them. You can only choose one out of many. So how do you store that in memory? The usual way of doing it is that you have an integer and you do something like this. So let's say you define that apples is 1, you define that pears is 2, and so on. And then you just have an int fruit, and you set it based on, based on this. But with an enum you can instead do like we did, so enum fruits, and then we can, for instance, do let's see if I get it in the right order this time. So let's say apples is 1 and pears is 2. Then instead of doing fruit equals 1, we should be able to do fruit equals fruits dot apples. And then the compiler will deal with these substitutions too. So in memory it's only saved as an integer, but you will be handling it as if it was like, I don't know, an object or something. Okay, so let's clean this up a little bit. And let's see if we got rid of that error message. So we make clean, we jump down a little bit, we clear the screen, and we run make. Now what? Expected identifier before string constant. Maybe it don't want these quotes. It's been a long time since I used enums in C. This looks a little bit better in VS Code, which is usually a good sign that it's going to work, but not always. Clean, jump down, make. Okay, it's gone, but it is complaining that on line 66 we are reaching the end of the function without a return. Wrong file, I guess. 66, and that is exactly right. That's why I have this, because I want to remind myself that put stuff here. Since this is it returns an int32, we can't just let's see, no, it's a main loop, an int8. It returns an int8, and we can't just not return anything. It doesn't work, you see. Alright, so now we have structured our data types a little bit, and that is usually a good way to start, because if you have very structured data types from the beginning, then it will be very easy to just add function after function, you making use of those data types. That's a good tip. Alright, so what's the next step? Let's keep on writing this main loop function. So when we have dealt with the actual connection, we want to save the state. So let's do something like, first we want to create the variable. So let's do state and state, and I want to have a constructor that creates one of these state structures. So I will simply do state equals to make state. I don't think we need any arguments to this one. Perhaps we could send the socket file descriptor if we do have that. And one more thing I want to have in the state, by the way. I want to have the process ID. So let's do an int16. No, it's not an int16 anymore, I think. The latest Linux version can have pretty big PIDs. So let's follow the standard and do PID-T in this case, which is basically a type definition for an integer, 32-bit. So, and we call this process ID, because it's always good to know all the process IDs. If we, for example, want to kill off it or something, if it's gets stuck or whatever. Alright, so let's make state, and yes, we wanted to have a socket file descriptor. And where do we get that? We get it from accept. So inside of S is the socket file descriptor, and S is a, what is it? Okay, we send it right here. It's an int32. So this will be the only argument of make state. Yeah, we just put S there. So now we have an empty state structure with only the socket file descriptor defined. Maybe we should also put the process ID in here. Did we get it from somewhere? We did not. So let's create a variable for that. So PID, PID. And instead of just doing the if statement like this, like if fork, we will do an extra parenthesis. And I will simply do PID equal to. So this is one way of coding that most people tells everyone to don't do, because this can be mixed up with this, they say. So in this case, we are comparing the PID to the return value of fork. But what are we doing in this case? We are assigning. So basically we take the return value of fork, we put it inside of PID, so both of these have the same value, and we check if this is true. So if it's non-zero, then we run this code. Yeah, that's right. This is the code that the main process will run, not the child process. So the state will be in the main process. So let's move this up a little bit. No, not there, but maybe there. All right. So if PID, after being assigned to this fork return value, is true, that means we did get a PID back, and that means we are inside of the main process. So we are running this. Otherwise, we are inside of the new child process, and that we will handle differently down here. But let's begin with the state. So we give this a socket file descriptor, we give it a PID. What else do we have in this? IP, port. I don't think we need to give those at inside of the constructor, right? No, I don't think so. So this will be that. Then we can manually put in the IP address there. So let's see how we do that. Where do we store the IP address to begin with? Client connected from, blah, blah, blah. We have host, we have port. And what is host? It is a... host, no, that's not it. Host, there it is. Okay, so it's a regular string pointer, and we get it from the return value of 2 dotted, which means it's allocated on the stack, and we can use it here as well. That's good. So first we let's see, we check that we have state. And what shall we do if we don't have a state? We will not abort entirely, but we will abort this. We will exit out of this function at least. Yeah, we kind of do. Sorry about my cat. He gets a little bit crazy when I'm locking myself inside of a room like this. Alright, so if we don't have a state, let's put out an error message of some kind. It can be a static string, so log err, and we say something like unable to create state. And well, there's not much to be done at this point. Let's see, what do we have? We have an int 8 return value. And how is it used? Let's see, while continuation return equals main loop s. Yeah. For now, let's just return 1. And if we have a state, we want to use it. So inside of state, we are going to, I don't have the greater than, there we have it. Okay, state, we want the IP address. So the IP should be equal to the host, and the port should be equal to the port, and we don't really have a request at this point, and the PID will be set by the constructor. Maybe we should move this up here so we differentiate a little bit between the 2 that is set in the constructor and the 3 that we can deal with on our own. It will create the request object, but it will just create an empty request object. That is my idea anyway. Okay, so now we have a state with these information, and we don't need to do a whole lot more, I think. So in this case we will just return 0, and then it will go to the next loop of this function, waiting for another connection. Let's remove those. But what shall we do inside of the child process? So we have already accepted the connection, so the TCP connection is established. The first thing the client will do is sending something like get slash and then the version supported of the protocol, something like this, and then to enter like this. And before that we will have a lot of different headers. So basically we will have like host, maybe we have something like content type, application/JSON, and all those things, a lot of different headers. So what we want to do is to parse all those headers and put them inside of our headers object. And then we put this inside of the state. We do also want to go through all the cookies and put them in a special kind of structure, which will be same as the headers, basically same kind of structure, and it will also be inside the request object and the state. So at this point though, I don't think we should start with the headers. Let's start by checking through what happens. Let's do this. This is a good starting point when you are a little bit unsure about what exactly the client is sending. So if we go to Code Planet and we start a netcat. Netcat is a program which acts as a TCP or UDP server and listens to one single request and shows it on standard output. So I will do LVVP, and let's say we listen to the port 8081. if I go to my web browser and I surf into codeplanet.drbirch.com, port 8081. This will just hang, but inside of here we get all this nice information. So this is a good way to find out how a protocol works. You can read all the manuals and RFCs and stuff, and that is good as well. But as a first glimpse of the protocol, I think this is the best way. Okay, how do I do page up on this Mac keyboard? Oh, the arrows work. Okay, so let's see. Okay, first we get this thing, which is kind of good because then we can just start by parsing this. So it's a method, it's the path, it's the protocol version, which we don't care about. And then we have the different headers, most of which we do not care about. The host might be useful in case we want to run several instances on the same server and on the same port, and differentiate between them by their different hosts. So basically we have one IP address and several DNS records pointing towards that IP address. But we'll deal with that when we get to that point. All I want to do at this point is parse this simple string. But even though it's a rather simple string, it's not always so straightforward to parse text. So let's see how we do that. Perhaps we should call a function which creates a request object. Yeah, that's a good way. I think I will change one thing that I said before. I mentioned that the request object were to be created by the constructor but left untouched, so zeroed out. I don't think I will do that. Instead, I will just leave it as it is, and I will let this part of the program create it instead. So we'll create a request object, which we will call rec. And we will set rec equal to make request. So we will have a constructor here as well. And what do we want to say to this one? Maybe we could just give it the socket file descriptor and let it parse all the things itself. That's pretty good, I think. So let's do that. We just give it S. And if we get an empty request object back, then we can close down the connection because there's not much to do here. We will do an error. So we did have a buffer, right? Yes, 128. So let's zero out that buffer. I will probably create a specific macro for these operations later, because I have been doing the same thing a couple of times now, and that is zeroing out the buffer and using the snprintf against the buffer size 127, and then the message. So let's see, we want to say something like unable to parse request from, and we give the IP address and we give the port number, because that's basically all we have at this point. We can't give the request or the path or the method because we were unable to parse the request. So let's just do this, and we will give the host and port like this. So now buff contains our error message, and then we will simply do log r and buff. And then we will exit with a -1 exit code. All right. So all we need to do is create those constructors, the make request and the make state. And the make request will be a little bit more difficult, since this will actually parse the request, including the headers and whatnot. But this state constructor will simply just allocate memory. So let's begin with the easy one. I will create a function definition for it first. So let's see. It will return a state pointer, and it's called make state. It takes 2 arguments, the first being the socket file descriptor, which is an int32, and then we have a PID-T for the process ID. Let me just see that it is correct. Yes. All right, so let's create this thing. So it'll be state make state, and we'll have an int32 s and a PID-T PID. There we go. And what do we need inside of this function body? Not much, actually, but we need some things. We need a state variable. That's probably, no, we need one more. Let's do an int16 for the size as well. We don't really need to put it in a variable, but I like doing it because it makes the code a little bit easier to read. So let's see. We will set the size equal to the size of struct s state, and then we want to allocate memory for the state. So we will ask for a state star casted malloc call of the size bytes. And since this is an int16, we need to do my little dollar, yeah. Let's see, it should be it's a $I size. And let's see, so if state 0, we return a state casted 0. Otherwise, we will zero out the entire structure. Size. And this needs to be casted into a int8 pointer. After we have zeroed it out, we want to fill in the blanks that we are able to do at this constructor level. So basically we'll do state and an arrow s, do we call it s? I think so, is equal to s, and state arrow pid is equal to pid, and then we'll just return state as is. Let me just double check the variable names. S and pid, that's right. Okay, so our program is taking form. Let's see. So the make request is the next part, and yeah, so let's create the function signature for that. So it will return a request. It's called make request, and the only thing it takes is an int32 socket file descriptor. And we'll go to the top here, make some room, and we will create, let's see, it's called request and make request. And what did we want to take? It's an int32s. So before we continue, let's just take 2 minutes break. I will put on the screen which says 20 minutes break, but we will not do 20 minutes. I will just do 2 or 3, so I can check on my cat, drink some water, etc. And then we will be back in a couple of minutes, okay? Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay guys, so we are back from the break. And I checked through the chat a little bit while I took the break. And there is a question, is there a benefit type defining integers instead of using the int type lib? No, not really. Not in a global kind of stance anyway. For me, it is a benefit because I don't like underscores. And these are called like u underscore int16 instead of simply int16 and stuff, so on. And typing underscore is really annoyingly difficult on a Swedish keyboard, which makes me very much not like them, and I try to never use them if I can avoid it. So that's why I define my own. What about calling it mkrick to be shorter? Well, we could do that. I think the reason why I didn't is because I have make state, which is the entire word, and I want to be a little bit, what's the word I'm looking for? Consistent. Yeah, that's the one, Nathan. We had a little bit of discussion with the enums, and it seems that we basically came to the same conclusion, you and I. That's good. Okay. So, do you have any questions this far inside with regards to the project or anything really? What do we have so far? Well, we do have a program which is listening for incoming TCP connections on the specified port. When we get the connection, we fork the process. The main thread will do some logging and creating of state. And the child process, which we are currently working on, will parse the client request. So that's basically it. Well, we could run it, but I'm not sure. We are missing one function. Well, maybe not. We do have this empty make request function, so perhaps it will work. Let's just do something like return let's request cast a 0. This way it might compile at least, but I don't think it will work very well. Let's see. So we make clean, we jump down a little bit, we clear the screen, and we do make. Boom. Okay, that's a couple of errors. I can see by the color, this annoyingly pink color, that we have forgot a little bit about the signedness, which is commonplace when we do this kind of stuff. At least when we do this kind of stuff this way. Alright, suggest parentheses around assignment used at truth value. Okay, so this is exactly what I was talking about. Some people say that this is, this can be, I can't find the word now, but you might think that this is a comparison and not an assignment. But I don't like that the compiler is telling me this, because if I chose this style, I don't want this kind of warning. And you usually don't do this by mistake, right? And then we have the signedness problem, we are sending a regular char-based string to our logr method, or logr function, macro even, and it wants an int8 pointer, so that's why. This is related, and this is the same thing, I think. No, not exactly. Pointer targets in passing, argument 1 of smprintf, different signs. Yeah, it's the same thing. The buff should be a char when we send it to smprintf, and not the int8 that it currently is. So that's the signed stuff. Yeah, let's start with that and see what happens. We go here and let's see if I remember all things. It's inside of the main loop, I think. Let's see. Here's one. This should be casted to int8, and this buff should be casted to a char. So you see, it's quite easy to have this kind of macros. Alright, so let's try compilation again. So we clean and we space down and clear and we do make, boom. And we scroll up a little bit. Okay, this is still the same. I will try to get rid of this warning. Control reaches end of non-void function. This is the same as before. We are not quite done with that function yet. What is this then? Port may be used uninitialized. That's interesting. Is that really so? And same with the host. Let's check this out. That is something that GCC did not check for before, but I can appreciate those kind of checks, because we really did forget about that, I suppose. Let's see. So we define the host here, port here. Let's see the next port. This is happening inside of the main process. And then we go to the child process and we try to use those values in the child process, and that we cannot do because there is no automatic communication between the two processes. They have their own memory mappings and stuff. So perhaps we should not log this from here. How can we do this in a smart kind of way? We want to get this error message logged, but only the main process has these. We could add some kind of intra-process communication, IPC, or we could create threads instead, either with the standard POSIX thread library or using my own needle threads library. But I think that's a little bit overkill for only putting out an error message like this. Maybe we could link this with some kind of ID number or something like that. We could use the socket file descriptor as an ID. Why not? So enabled parse request with ID this. We remove here. Let's see, what do we put in here? We set the S, right? Yeah. So this should get rid of both those error messages along with all the extra stuff that relates to that. So we do make clean, we do move down a little bit, and let's go again. Okay, now we're talking. We have this annoying thing. And this is right, and then it compiles. That's pretty awesome. So if we run web dev, and let's put it on port 8082 for instance. Let's do this. I don't know if it's running. We don't get any message on the console. We do get the messages. Let me show you. If we do Control Z, this will not end the process. It will just minimize the process. And then we can do BG to put it inside of the background. And if we go into the root access and move to our... No, we don't need to move anywhere since we're using this new journal thing. So we could just do this, I guess. Okay. We need to tail this. If I can do the pipe sign, there we go. Okay, so let's see, web dev. Here we have something. But this is when here it is. Server successfully listening to every IP address and port 8082, which means that we should be able to, let's do this. Let's do tail. I'm not sure if this works along with the journal. Let's try it out. And we want to, where is that pipe sign? No, not that. There. We want to grep for web dev. Let's just see the first message again. No, it terminated. I don't really like that thing. Maybe there is some kind of option to this journal D command. If we do tail detail no tail, it was so much easier before in Linux when we just had different ASCII-based text files as logs, so we could do all the different operations that we are used to directly on those instead of relying on this Oh, I really hate journal D and system D and all those new things. If we search for live or something, show a live log display. So we do F. Okay, we do journal D-F instead of tail-F. And we can probably do the way they do instead. This is probably the same as grepping, right? And now we go to our browser and we go to the port of 8082, like so. And let's see what happens inside of our logs. Maybe it needs to be an exact match here. So webdev.c. Or maybe this is just trash. Alright, so let's do it manually instead. Why do Linux use this useless system? Systemd, journald. Why? Before we had the system 5 tools, which was a lot more straightforward. It always worked, and there were no ambiguities. But, well, time has passed. Where were we? Yeah, journald, and we want to grep this for webdev.c. And this is what we get. So we get this, unable to parse request. And we also have this before that. Client connected from 000. That's a whole lot of zeros there. And I don't think that is right. No, it's not. We should actually get a real IP address there. Why don't we? What happens if we close this down and we run this on port 8083 and we run it against the local host IP address, like so. We put it inside of the background, we go back to our root shell, and let's see, what was I thinking? Right, what if we were to do a curl against, curl is a command for doing a web client connection. So if we were to curl localhost port 8083 something, it should hang like this. I will BG this process and close this down and FG this. No, we need to check the logs, that's right. So let's do journald D. And let's try this U command, webdev.c. Webdev. No, of course it doesn't work. Why would it? let's do it the old-fashioned way. No, that's not the right key. There we go. Okie dokes. So let's grep web dev. Okay, so let's see. Unable to parse the request, and it still says all zeros. That's a little bit weird, right? Well, where do we get the host and the where do we get the IP address and the port from? We do the, let's see, the main loop. We do accept. And we give it the sock, which is this, and we give it a reference to the size, and size is 0. Perhaps this is the, no, I think it's man page time. So let's close this down and this, and let's do man to accept. And what do we want to see? We want to know what this address thing, how it is being handled, and how this address length works. So let's see. The argument address is a pointer to a sock address structure. This structure is filled in with the address of the peer socket as known to the communications layer. The exact format of the address returned is determined by the socket's address family. When address is null, nothing is filled. Alright. So address should be equal to the address of what we want to receive. That kind of makes sense. So let's see. We will just do a size of struct sock. No, let's see. Struct sock address. I think this is what we need to do, right? Alright, let's try this once again, and then we will perhaps call it a night. The time is soon 3 in the morning here in the cold north. So let's see. Where were we? Yes, we need to compile this thing first. So we do the standard procedures. We will run our code. Let's run it the same way as we did last time. So web dev against localhost, and we will put this into the background. We don't need to go in as root just yet. We will links to HTTP, localhost, no, localhost port 80, 3 something, and let it rest a little bit. That should be enough. And then we will log in as root, and we'll do journal blah blah blah, and we grep for webdev.c. Successfully listening to 127 blah 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 8083. Okay, so now that works. So now we have the basic structure set up for our project. What I will do is I will copy this to the repo, and I will, as soon as I will release this recording of this live stream, I intend to open up the repo. And if you don't know about the repo, it is https repo.drbirch.com. Since this is a GitHub free zone, my YouTube channel, I have made my own repo system. So basically, this project is webdev.c, and as you can see, it is a lock on this one. But as soon as I publish the live stream recording, which would be in a couple of days, I will open up this directory for 48 hours, as we decided together last time. And if you want to access older stuff, you have to become a member. So that's basically how this works. I need to pay my rent, you know. Alright, so before we end this session, do you have any additional questions to me about this project, about anything else? Did you like this episode? Was it interesting? Did you learn something? Okay. Thank you, Tony. I'm glad to hear it. Okay, so a new episode will be released perhaps, I don't know, in 24 hours or something like that. If you want a little bit of sneak peek, I can show you the image of the project. Let's see if I can resize that to the window somehow, but I think I can. Let's see, where is it? Thumbnail, here it is. Oh, it was really big. So let's see if it fits. Alright, here it is. So this is the next episode, which is going to be released. I hope you will find it interesting. And if you like this episode, please like and subscribe. And thanks for watching. And thanks for today. I love you guys. Bye bye.